Hello friends, this is going to be one of the videos among the 20 videos on practical data science. Now in this I decided to talk about the basics of RNN, recurrent neural networks and long-term memories. As you can see on the screen, typical diagram of an RNN usually looks like that, and LSTM looks like this. Now we will go through the basics of these two. So this is going to be an overview of our video, and we start with the perceptron. And what is a perceptron? Perceptron is a single artificial neuron or a node. It is the basic building of any artificial neural network. So, the inputs are always in binary. Perceptron takes multiple binary inputs and applies weights to these inputs, sums them up, and then passes the result through an activation function to produce an output. So, a single perceptron can only learn linearly separable functions, but when combined in layers to form a multi-layer perceptron. Now, neural networks can learn more complex nonlinear relationships and patterns in data. Now, this is how a perceptron looks like. This is having the limitation, it has got binary inputs actually, 1 or zeros. It's like you can say if he is a man, yes or no, like that. It will be all 1 or zeros. Whereas suppose you have some data which are 1.453, which is like some decimal pointed values, then perceptron cannot be used. So these are the inputs. It's like x1, x2, xn, like that, and there is a bias also involved, and first it goes through a summation. It simply add x1 w1 plus x2 w2 plus xn wn plus b, something like that. After that it goes through an activation function, and activation function, this is what activation of their sum, which has gone through this b plus summation of all these, nothing but you are adding all these. So you pass through an activation function, and after that you get the result y. This is what it is. So you can write y is equal to an activation of all the sum. Now, what is a neural network? Neural network are a type of AI modeled on the human brain and nervous system. See, we try to understand the biological neuron and then try to create an artificial neuron which functions similarly. So, an artificial neuron, what it is? When they are passed through the data, it generates identifying characteristics from it without being pre-programmed about the understanding of the data set. So all these things, we will understand a little later. So a typical neural network looks like that. It has got x1, x2, x3 like that, input layer, and the output layer. This is where the output comes out. It's like a man or a woman, or it could be apple or orange, something like that. And these are the hidden layers. It has got 3 hidden layers. Now a typical artificial neuron works like this. Let's say you have x1, x2, x3, which are the 3 features of human, and b is the bias. Then if you see one neuron which is here, it is summation. That means x1 w1 plus x2 w2 plus x3 w3 plus b, which is nothing but the a1. That is what this block produces. It's a summation. After that, the summation goes through a sigmoid function. In this particular, g of x is nothing but a sigmoid of a1, sigmoid of all the additions. sigmoid, you know that 1 divided by 1 plus e to the power minus x or whatever actually. So this is a sigmoid function. So you can go through this somewhere else, but what is a sigmoid function, etc. It's very simple. It produces an output between 0 and 1. So, and this produces H1. So here also H1, if it is producing H1 here, it may produce H2, it may be H3, and then combinedly again it goes through the summation and then activation function and produce another H. So now neural networks can learn to perform variety of tasks like classification, mango or orange, prediction, like you are predicting the age of a person or whatever actually, then predicting the expense of a company, or generating new data such as text, images, music, etc. This comes under generative AI. Now, neural networks are used in a wide range of applications, including computer vision, natural language processing, you know, where you can speak and speech to text, etc. comes under that. This is like a AI camera, the speech recognition, and fraud detection, etc. Now, what is a recurrent neural network? That is what we want to understand. This is what is used in LSTM and sequential data processing, which we are talking about in these 20 videos. Now, RNN is a type of artificial neural network designed for sequential data. When, let's say, the data is coming every second, first data, then second data, third data, timestamp data, then you need RNN. The key feature of RNN is their ability to capture and utilize temporal timestamp dependencies data. What it is? Each node in RNN has a hidden state that serves as a memory. You know, this is the first neural network which has the memory. You know, it has got a memory effect. Now, the hidden state enables make RNN effective for tasks like time series prediction, natural language processing, and speech recognition, etc. They are incorporated in popular applications like CD, voice search, Google Translate, etc. So this is how an RNN looks like. See that, suppose the timestamp data are coming xt and one timestamp before, one timestamp after. See that, how it is. This is the input coming as I showed in the earlier diagram. Like if you remember this, if you look at this diagram, you know, some H comes out at the end. Some H comes out. So same way, you can think that this is xt1 and you know, you have some H, and from that H it produces a Y. And you know, at time t is equal at time t, that is time t, the current time, this is one timestamp before, this is one timestamp after. You see that from one artificial, you know, it is not that, you know, you have to create one artificial neural network here, another artificial neural network here, another artificial neural network here, etc. You can have a feedback mechanism, you know, by which the earlier weight can get added to the HT and create a new weight. So, time-stamped weights, different weights. So, here it can be expressed as, so that means for time t is equal to t1, it may be looking like that, t2 it may be looking like that, t3 it may be looking like that, but the only thing is the weights are differing. Weights are propagated from the previous timestamp to the current timestamp. Then S passed to the next timestamp. It is like that. So every time it switches. Time t1, time t2, time t3, etc. So HT can be expressed as activation function of say WXT into XT. See that this is like a earlier X1 W1 like that, you know, plus WHT1 minus into HT1 is 1 is like earlier, plus a bias. So it is looking like a artificial neuron which we discussed earlier. Now output is given by activation function of HT multiplied by, see that, WYT plus BYT, something like that. So now this is the YT, the next prediction. This is YT, see that, and weight of YT, this is something like that, B of YT, something like that. This is how it is. Now here in this particular case, Xi is the input values, Wi is the weights associated with the inputs, B is the bias, this is summation, activation function, etc. Now long-term memory, LSTM stands for long-term memory in a neural network, and it has got four things: a cell, a forget gate, input gate, and output gate. Cell is working memory that stores the information which are modified and directed by three gates. So forget gate tells about those stored information that is irrelevant, you can forget that. And input gate tells about the new information that has to be added to the cell. Output gate is the final, tells about those stored information that should be part of the current output. Now in backpropagation, in LSTM is an advanced form of RNN, and there is something called a vanishing gradient problem because of that which RNN has, and because of that only people came out with a new neural network, that is LSTM. So backpropagation is a technique to minimize the error function by adjusting the weights and biases of the neural network. Here after each iteration the network weight receives an update which is proportional to the partial derivative of the error function with respect to the current weight. So new weight is created, that actually loss function is, this is the loss function and this is the learning rate. And this gradient start disappearing. So in RNN, during backpropagation, for deep architecture, for long-term gradient becomes extremely small or extremely large. If the gradient becomes extremely small also it disappears, extremely large also is a problem. So that is where this LSTM, this is called a vanishing gradient issue. And LSTMs are designed to address the challenges of learning long-term dependency in sequential data using memory cells and gate mechanism that allows the gradients to flow unchanged. This way, the network also effectively learns which information might be needed later in a sequence and when that information is no longer required. Now, see, this is how a complete LSTM looks like. A forget gate, input gate, then an output gate. And we are going to explain this complicated diagram here. So this input, the forget gate, what is forget gate? So input data comes and there is a hidden layer. From the hidden layer HT minus 1 comes. And it gets added up and it goes through a sigmoid function and it produces, this is a sigmoid of this, that is called a forget gate. Now in input gate, actually what happened, again from the hidden layer HT minus 1 comes, input comes in and forget gate is gone now. It comes to the input gate. Input gate, this is tanh is the function used here instead of sigmoid because it has got a variation from -1 to +1, whereas this sigmoid has got 0 to 1. And this is how an input gate looks like. Whereas output gate actually is after forget gate and input gate, actually the output gate comes in. So here also you are using a sigmoid neuron, sigmoid function, activation function, and also a tanh function, and this is how it looks like. Now this is the basics of RNN or LSTM, and this I just explained because you should know at least some basics of all this, so that you know how LSTM forecasting can be done, how neural networks can be made for forecasting, how it can be taken to a proportional integral derivative, control theories, etc. Thank you.